Hello friends, today we will discuss the important topic for IIT Foundation as well as for 9th and 10th CBSE and ICSE students trigonometry, powered by Perfect Academy, Focofitro Educational Services LLP. You can get best video lectures, assignments and free online tests by just subscribing to our YouTube channel. Well, let's see what we will learn exactly in this topic of trigonometry. We'll learn introduction and history. We'll define basic trigonometric ratios. We'll also calculate trigonometric ratios of various angles, complementary angles. Finally, we'll discuss applications of trigonometry, solved examples on trigonometry and applications of trigonometry, and we will also give you few problems to work out as exercise. Well, in the beginning, let's discuss introduction and history of trigonometry. As this word trigonometry has tremendous importance in the field of mathematics, let's talk about this word trigonometry. Now, if you will search about this word trigonometry in any dictionary, you will get several definitions about trigonometry. The basic definition of trigonometry says, trigonometry is the branch of mathematics which deals with measurement of angles and sides of triangle. Well, if you will try to find out the origin of this word trigonometry, there are two distinct group of people who will argue at their origin. One set of people says this trigonometry has a roots in Indian mathematics because this word has been derived from Sanskrit word trikonamiti, and Aryabhatta has contributed so many things about trigonometry. A great Indian mathematician who has also invented zero has contributed a lot in the field of trigonometry, which indeed became trigonometry after the entry of Alexander to India. The other set of people says that this trigonometry has its roots with Greek mathematics, where they say the word trigonometry is derived from Greek roots. Trio means, of course, 3. Trio means 3. Gonia represents the angle, gonia, and finally we have metron. These 3 Greek words, see, trio represents 3, gonia represents angles, and metron represents measurement. So the science or the branch of mathematics which deals with triangles, okay, or the angles of the triangles is called as trigonometry according to them. However, inarguably, trigonometry has immense importance in the practical world as well as in the field of physics. Okay, so we will be discussing trigonometry at the basic level to the scope of 9th and 10th standard in this session. Here are these two gentlemen who have contributed immensely in the field of trigonometry: the great Indian mathematician Aryabhatta and the great Greek mathematician Pythagoras, who has given us one of the basic theorem about the right angle triangle, which can be said to be the basic theorem of geometry. Suppose if we have the right angle triangle ABC, okay, then we can say by using Pythagoras theorem that AB square plus BC square, that is base square plus height square, is equal to hypotenuse square. The side opposite to 90 degrees is referred as hypotenuse. Fine. After discussing some points about introduction and history, let's enter directly into the definition of trigonometric ratios. Now, before we actually define the trigonometric ratios, we should know few basic things about the trigonometric ratios and the methods to define them and the methods, of course, to remember them. There are 6 trigonometric ratios we have. Now you might have observed right from the beginning I am drawing this right angle triangle, because throughout this chapter our concentration is on this right angle triangle. So let's say I have this right angle triangle ABC with B as 90 degree or right angle. I will consider any of the angles C or A as theta. Theta is just a Greek representation of the angle. You can see here also theta is drawn. With respect to this theta, I will consider AB as the opposite side and BC as the adjacent side. Okay. Obviously, we know the side opposite to 90 degree is referred as hypotenuse. So I have, with respect to theta, AB as opposite, BC as adjacent and AC as hypotenuse. Now, with the help of the given or in fact drawn triangle, let me write one simple statement. OHA, HOA. A simple statement consisting of 6 distinct letters, OHA and HOA. Then I will group them 2 at a time. So OH will have one group, AH will have one group and OA will have one group. Okay. Now I will start writing the titles of 6 distinct trigonometric ratios: sine, cosine, that is represented as cos. Then I have we have sine, cos, tan, cot, sec and cosec. Right? Well, now after writing these ratios in clockwise manner, sine, cos, tan, cot, sec, cosec, mind you, these are 6 basic trigonometric ratios. I'll put arrows on each first letter. Okay, so I'll put arrow in clockwise manner to O, A and O, and while returning I'll give arrows to A, H and H. You can see this table is drawn here in the same manner. We have written one statement OHA, HOA. Then I have written the titles of the trigonometric ratios: sine, cos, tan, cot, sec, cosec, and finally I have used these arrows. You might be wondering how exactly we will be defining trigonometric ratios by using this table. Always remember, trigonometric ratios are ratios of sides of the triangle taken with respect to any of the certain angle. In this case, I will consider theta as that certain angle. So, as this table says, how I will utilize this table? See, sine theta will be opposite side to hypotenuse, that is O by H. So if I observe the triangle, either the triangle what I have drawn and the triangle which is already given in the slide, it doesn't matter, both are really same. So O will be AB, that is opposite side will be AB and the hypotenuse will be AC. So sine theta is AB by AC. Then we have cos theta. Now you can also define cos theta. Cos theta is A by H, that is adjacent by hypotenuse, which can be said as BC by AC. Finally, we have tan theta. Tan theta can be written as O by A. O is AB, A is BC. Similarly, you can define cot theta, A by O, which is nothing but BC by AB. Then we have sec theta, H by A, that is nothing but AC by BC, and cosec theta, which is obviously H by O. which is AC by AB. There are some more observations we can make by using this table, but this table is known as the basic table of trigonometry. So with the help of this table, later on we will be defining few other relations also, but at least for defining the trigonometric ratios, you should remember this table. This table is very easy to remember as we have drawn it in the beginning. You can write a simple statement OHA, HOA, then you can go on in clockwise manner. Write the titles of trigonometric ratios as sine, cos, tan, cot, sec, cosec. Fine. All these trigonometric ratios are systematically defined. So you can please note down these trigonometric ratios. You can see sine theta is AB by AC, cos theta is BC by AC, and so on. These ratios have been defined till cosec theta. I hope you should have recorded the basic table which we have used, because we will be using it enormous times to define few other relations also. Now, as we have understood the basic definitions of the trigonometric ratios, I will use now that same table to define few reciprocal relations. Let me again go back and draw the triangle ABC in which B is right angle. So this AC will be hypotenuse. Doesn't matter whatever you consider as theta. But again, if I will consider the same as theta, this will be O, this will be A. You know the table already. OHA, HOA. They will be grouped 2 letters at a time. Sine, cos, tan, cot, sec and cosec. I will put arrows in the described manner. Now, if you will observe, sine, cosec, sine of theta and cosec of theta are represented dynamically opposite to each other, isn't it? Also, cos and sec are represented opposite to each other. Tan and cot are also represented opposite to each other. Now, if I will try to define sine, sine is opposite by hypotenuse, right? Whereas if I will try to define cosec of theta, it will be hypotenuse by opposite. So if I will observe both these relations, then I can easily say sine theta is reciprocal of cosec theta, as well as I can also write cosec theta is reciprocal of sine theta. Similarly, we can comment on cos theta is reciprocal of sec theta and sec theta is reciprocal of cos theta. Also, we can say tan theta is reciprocal of cot theta and cot theta is reciprocal of tan theta. These are very important relations, because when we have to convert them into one form to other form, they will be very, very useful. The same reciprocal relations are derived step by step, as you can see here. Sin theta is 1 by cosec theta is 1 by sin theta, and all the three ratios are listed there. The next point of our discussion is this quotient relations. Now, in this triangle of ABC, where B is the right angle and I have considered C as theta, you can take A also as theta, opposite, adjacent, hypotenuse. By now you should be thorough with the table. So if I want tan of theta, tan is given by last two letters of our statement, right? OHA, HOA. So tan should be opposite by adjacent, right? Tan should be opposite by adjacent. Now what I will do, if I will use this ratio O by A and divide numerator as well as denominator by hypotenuse, then the ratio will become O by H divided by A by H. I am just dividing numerator and denominator by H. Then what will happen? If you will observe the table carefully, you will understand that O by H is nothing but the definition for sin theta, because sin theta is given by first two letters OH and cos theta is given by next two letters, that is AH. So in fact I can say as OH, O by H represents sin theta and A by H represents cos theta. I can call tan theta is equal to sin theta by cos theta. Very important quotient relation. So here we can express tan of theta in terms of sin and cos. We have recently seen cot theta by the reciprocal relation is equal to 1 by tan theta. So I can also say cot theta is equal to 1 by tan theta, that is 1 by sin theta by cos theta, and hence I should be able to write cot theta is equal to cos theta by sin theta. These two are referred as quotient relations, where tan and cot are expressed in terms of sin and cos. Here step by step they are derived. Well, next is trigonometric ratios of various angles. This is one of the most important part we will be discussing throughout this lesson, because when we will start using trigonometric ratios in practical cases, most of the time we have to use trigonometric ratios of some specific angles, as in you can say 0 degree, 30 degree, 60 degree, 90 degree, one more is there, 45 degree. So all these trigonometric ratios for specific angles we have to define. So we have to actually find out what is sin 0, sin 30, sin 45 degree, sin 60 degree and sin 90 degree, etc., etc. Similarly, we have to find out cos as well as tan. In fact, if you can answer for what is sin and cos, by now you should be aware of the fact that if you know sin, you can define cosec. If you know cos, you can define sec, and if you know sin and cos, you can find out first of all tan, and then you can even define cot. In this article, we will try to find out the method to actually calculate these values, because in most of the books, if you will see, even with NCERT, the issue is they have given a table for students to mug up, and most of the students I have seen, they are mugging up these values. So instead of by-hearting these values, if you will learn the way of memorizing them logically, then definitely it should help you. For that, I will consider a theory which is called as three-triangle theory. Three-triangle theory. Now, what is this three-triangle theory is all about? I will consider three triangles ABC, ABC, ABC always, where B is always 90 degree, you can see. Okay. And in each case, I will consider the hypotenuse is to be 1. The only difference I will have everywhere is the internal angles. I know the sum of internal angles of the triangle is 180 degrees. So I will distribute the rest of the 90 degrees as 30 degree, 60 degree for the first triangle. So this triangle is 30, 60, 90 degree triangle. Second triangle is 45, 45, 90 degree triangle. And third triangle, this type of triangle will never actually exist. So I will call it as a false triangle, because you can never have any angle as 0 degree in practical case. Okay, if at all we have a triangle. So I have 90 degree, 90 degree and 0 degree, which is false triangle. Now everywhere I have denoted already, as I said, the hypotenuse to be 1. Now in 30, 60, 90 degree triangle, if you will concentrate, you will understand from the basic geometric theorem that the 30, 60, 90 degree principle says the side opposite to 30 degree, that is BC, is 1/2 of the hypotenuse, that is AC. The side opposite to 30 degree in 30, 60, 90 degree triangle has to be half of that of hypotenuse. So by that logic, it should be 1/2 into 1, that is 1/2. So BC is equal to 1/2. Now if I will use this value of BC in Pythagoras theorem, what I should get? I know AB square plus BC square is equal to AC square, right? So out of that AB I have to find out, that should be equal to root of AC square is 1 minus BC square is 1 by 2 the whole square, so that is 1 by 4. So it should be root of 3 by 4, or it can be written as root 3 by 2. Hence side opposite to 30 degree is 1 by 2, whereas side opposite to 60 degree will become root 3 by 2. AB is equal to root 3 by 2. As it is a side of a triangle, I will not take the negative root. So I came to know about all the sides here. Now let me go and check with the 45, 45, 90 degree triangle. Here the important thing, if you will observe carefully, you will understand, this is not only the simple right angle triangle, it is right angle isosceles triangle, because from the basic principle of the triangles you will understand, if two angles are equal in the given triangle, then two sides opposite to them are also equal. So in that case, if I will consider AB, which is opposite to this 45, is equal to x, then BC also has to be equal to x, right? So if I use the Pythagoras theorem, what I should get? AB square plus BC square is equal to AC square. So x square plus x square is equal to 1. That is 1 square is nothing but 1. So 2x square has to be 1, x square has to be 1 by 2, and x should be equal to plus or minus 1 by root 2, but I will not consider the negative root here. So I will get both sides of this 45, 45, 90 other than hypotenuse are 1 by root 2. So we have simplified basically this triangle as well. Now finally we have one more isosceles triangle, because here also we have 90, 90 and 0. So if hypotenuse is 1, the other side opposite to this 90 degree also has to be 1, and the remaining is 0 by using the Pythagoras theorem. Now as we know these three triangles, now let me go and check with the sine, cosine and tan values of various angles. Now how to find it? Let's say for 0 degrees we are talking about. Now 0 degree is available in this third triangle, so I will concentrate on third triangle. For 0 degree, this is the opposite side, right? So for 0 degree, opposite side is also 0. Adjacent side is equal to 1, and hypotenuse is obviously 1. Sine of 0 should be opposite side by hypotenuse, so that should be 0 by 1, that is nothing but 0. So sine 0 is equal to 0, right? Well, cos of 0 has to be adjacent by hypotenuse. Okay, here in this case it is 1 by 1, so it should be 1. So cos of 0 has to be 1. So sine 0 is 0, cos 0 is 1. Now tan is sine by cos, right? You can calculate even by basic definition. Tan is opposite by adjacent, that is 0 by 1 in this case, so it will be 0. Or here you can calculate tan is sine by cos, 0 by 1 is 0. So by using this triangle I can find out the trigonometric ratios for 0 degree. Now next is, let us say 30 degree I have to find out, so I will concentrate on this triangle, isn't it? So for 30 degree, opposite side is 1 by 2, adjacent side is root 3 by 2, and hypotenuse is as usual 1. Now sine 30 has to be opposite by hypotenuse, that is 1 by 2 by 1, that is nothing but 1 by 2. So what is sine 30? 1 by 2. Then we have cos of 30, which has to be of course adjacent by hypotenuse. So adjacent is root 3 by 2 by hypotenuse, so cos 30 is root 3 by 2. Now if you know sine 30 and cos 30, it is very easy to find out tan 30, because tan 30 is sine 30, that is 1 by 2 divided by cos 30, that is root 3 by 2. This 2 and 2 will get cancelled, I will have 1 by root 3. So tan 30 is 1 by root 3. Similarly, you can go on and calculate 45, 60 and 90 degree ratios also. Next, trigonometric identities. Now, there are three basic trigonometric identities derived from very simple method. We use, in fact, so many students use them in their routine trigonometry calculation, but they don't know how to derive them. The derivation is not a big part, it's a very simple thing and very basic things also. Let's say I have again a triangle ABC where angle C is equal to theta. So I should know in the beginning itself what is sine theta. It will be opposite by hypotenuse. So AB by AC. Cos theta should be adjacent, that is BC by hypotenuse AC. Now in the beginning I will just write these two ratios, okay, and later on probably if we need we will write some other ratios. But let us say if I will apply Pythagoras theorem to this triangle ABC, then I will write AB square plus BC square is equal to AC square, right? Now dividing both sides by AC square, what I will get? I will get AB by AC the whole square plus BC by AC the whole square is equal to 1, right? But if you will see with this, I will get AB by AC is nothing but sine theta. So I will write it as sine of theta the whole square plus cos theta, cos of theta the whole square is equal to 1. Sine of theta the whole square and cos of theta the whole square are also written as sine square theta plus cos square theta is equal to 1. This is referred as first trigonometric identity, which is just obtained by using the Pythagoras theorem. Now in the same manner, if I will divide once by AB square and simplify, and also if I will divide the same equation once by BC square and simplify, I will get two other trigonometric identities. Those two trigonometric identities are 1 plus tan square theta is equal to sec square theta, the second trigonometric identity, and third one will be 1 plus cot square theta will be equal to cosec square theta. You can also try it by using this Pythagoras theorem, dividing alternatively by AC square first, then you will get this, by using AB square and BC square you will get these two. They are calculated here. We know from Pythagoras theorem AB square plus BC square is equal to AC square. Dividing both sides by AC square we will get the following thing, and then we will get the first trigonometric identity. Similarly, by dividing BC square and AB square, we will get 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. Now, if I have to remember these three trigonometric identities, then I can use the earlier table itself, the table by which we have defined trigonometric ratios OHA, HOA, sin, cos, tan, sec, cot, sec, cosec. Now in this table, what I will do is I will just draw the arrow pointing towards sin as well as cos, which gives me sin square theta plus cos square theta is equal to 1. Then I will start arrow from tan and I will just bring it till sec and show the pointer here, and I'll write 1 here, so that I will get tan square theta plus 1, where it goes sec square theta. So 1 plus tan square theta is equal to sec square theta, which is nothing but our second identity. And the third one I will represent in the table like this. It's already done, but just to show you the marking, I am just doing marking once again. So it will start from cot, so cot square theta, I will write plus 1 again here, plus 1 is equal to cosec square theta. So basically you can use the same table to define trigonometric ratios, to define reciprocal relations, okay, and also to remember the trigonometric identities. So it is immensely useful table and you should get used to the table as soon as possible. Now the next thing is trigonometric ratios of the complementary angle. First of all, we have to understand what is the concept of the complementary angles. Now suppose I have a triangle ABC, then I know angle A plus angle B plus angle C has to be 180 degrees by the basic geometry of triangle. But as we know, this angle B is a right angle, I can write angle A plus angle C is equal to 180 minus angle B, but angle B is 90 degrees, so it is 180 minus 90 is equal to angle A plus angle C. So basically I got angle A plus angle C is equal to 90 degree. The two internal angles of the triangle whose summation is equal to 90 degree are actually called as complementary angles of each other. So angle A is complementary angle of C and angle C is complementary angle of A. Now in this case, you have to also understand angle A can be written as 90 degree minus angle C, and angle C can be written as 90 degree minus angle A, right? Well, so this is the small information regarding the complementary angles. Now we will try to find out the trigonometric ratios of the complementary angles. Again, in this triangle ABC, as you know, B is 90 degree, C is represented as theta. We know this angle A is nothing but 90 minus C, that is 90 minus theta, right? So suppose if I am defining sine of theta, for theta this is opposite and this is adjacent, this is hypotenuse, so sine of theta has to be AB by AC, right? So I will call, let us say for now, this as equation 1, and cos of theta has to be adjacent by hypotenuse, that is BC by AC, equation number 2. Now let me define sine and cosine for 90 minus theta and see the magic of trigonometry. For 90 minus theta, this BC is the opposite side and AB will be the adjacent side. I will put prime on them so that you will not get confused, O prime and A prime, and you have the same hypotenuse of course. So sine 90 minus theta, whatever angle might be, but sine is always opposite by hypotenuse, so it should be BC by AC. Similarly, if you will find out cos of 90 minus theta, you should get AB by AC. So if you will observe equation 1 to 4, you can realize that sine of 90 minus theta is nothing but cos theta, whereas cos of 90 minus theta is equal to sine theta. All these relations are described here. Sine, cos, tan are written. Then sine of 90 minus theta, cos of 90 minus theta and cot of 90 minus theta are calculated. And by equating them, we can understand sine theta is cos 90 minus theta, which we have also derived. Cos theta is sine 90 minus theta and tan theta is equal to cot 90 minus theta. Okay, fine. Now let's go for few solved problems using information whatever we have learned so far.